Okay, let's go ahead and get these last two pages done and out of the way for our notes. Again, I'm going to try to go through as much as possible during our Zoom meetings. You just never know how it's going to go, if it's going to be good connection or not. I don't want us to not get some of the notes, so that's the reason for the videoing. Again, though, if you don't need to watch the video, then don't watch the videos. But here it is for the last couple of pages. We call this part kinematics. And like I said earlier, kinematics is a study of motion, or the study of bodies in motion. I guess we can say objects in motion. It's a way of combining two or more of the equations we've already learned, okay? So when it comes to our equations that we're going to, I guess, talk about, we need to go ahead and just recall what we've already discussed. And so one of them was displacement. Remember that one? That was delta x, or if you wrote a delta d equals x sub f minus x sub I. Velocity was v equals d over t. And they only have velocity, they don't have speed, because again, velocity and speed are interchangeable. That's also the d over t. And then the next one, acceleration, equals final velocity minus initial velocity over t for time. Many times you'll see delta t, okay? So those are the equations that we've already discussed and talked about. The lowercase d, or, and I'm going to put an x, d slash x, are used for distance or displacement, position. All of those words mean the same thing. Our units we prefer to use as a lowercase m for meters. V sub I is initial velocity. We prefer to use meters per second. V sub f is final velocity, again meters per second, a lowercase m. T stands for time. We prefer it to be in seconds. Lowercase a is acceleration. And meters per second square, again, it could be kilometers per hours per second. Okay, there's many different variations of all of them. Whenever we use the words from, rest, again, words in physics have number value. Okay, so it's important to know that if we use the word from, that's my initial, okay, velocity, and I'm initially starting off at 0 meters per second. When an object comes to a stop, if you're coming to a stop, then we're talking about final velocity, and that's going to be 0 meters per second, right? You're coming to a stop. Constant velocity, if we use the words constant velocity in an equation, then we mean that there is no acceleration. So 0 meters per second square. Am I saying that it's not moving? No, it could be moving, but I don't know what the velocity is. I just know that the velocity is constant, but I do know that the acceleration is 0, okay? So those are all some important things to keep in mind when talking about these equations. We call them kinematics. Kinematic equations. Do you need to memorize these equations? No, you do not. There is one little trick thing that you are going to need to memorize later on, but you'll see it in another set of little notes that we're going to talk about later this week. Okay, so all of them are considered to be our kinematics. But then we get over here to the back side, and we're going to talk about these. I call them like the Super Power Ranger morph ones. Okay, our basic ones that we've talked about, right? Speed equals d over t, v equals d over t, a equals v sub f minus v sub I over t. Those are what we've talked about, as well as the displacement, x sub f minus x sub I. Here is a new one. this new one here is using what we've already talked about and like combining into like a Super Power Ranger morphed one. This equation is acceleration equals final velocity squared minus initial velocity squared over 2 times the displacement. Or, this is the new one, A equals V sub F squared minus V sub I squared over 2 times D. Okay, not square it, but 2 times. Then the next one, which is another superhero Power Ranger morphed one, is displacement equals V sub I times time plus 1/2 A T square. Okay? It says here you just need to identify the variables that are given to you in the word problem and one variable that you're actually going to be looking for. Then choose the correct equation to solve for the missing variable. At times, you may have a 2-step problem that may need to use 2 of the equations to get to the right answer. At times, you might actually have a 3-step problem. Part 1 may be the conversion through the metric system first, and then a 2-step part problem, okay? So there are going to be some tricky problems to look at. Let's go ahead and get to this last page. This last page is more or less, it's a flow chart to kind of help guide you, okay? So in this flow chart, when we're using it to help guide us, there's a couple of things. First thing is, don't we kind of know our speed? Like if we're looking for speed or velocity, that's pretty easy cheesy. Like it's not going to be some big, extensive, crazy problem to solve for. So if we're looking for speed equals D over T. No direction because it's a scalar. If we're looking for velocity, V equals D over T again, but yes, direction. Those two are pretty easy. But if somehow acceleration is involved, then yes, we're going to have direction because it's a vector quantity. And we're going to go ahead and do here, step 1. You're going to ask yourself, is displacement or distance in the equation? So first thing is, we know if it's a speed or velocity equation. Those are super easy cheesy. Then if we get to an equation that's a little bit more complex and it's going to have acceleration in it. How do I know acceleration is part of it? Because there's probably some type of direction. Man, I thought I had my cameras fixed. I guess I didn't. Sorry, let's go ahead and try to fix this here. So I want to get this part done with our notes. Trying to see if I can get this, to hold down. So close to being done with our notes. Nope. I'm gonna have to pause for a moment. Okay, so let's see if this can hold up for a little bit longer so we can finish these notes here. So, next part here is you're asking yourself, is acceleration involved? And if you're saying yes, then you need to ask yourself, is displacement? Is somehow they're talking about distance? Is distance involved? If the word distance is involved, yes, you're going to go this route. If you say no, then you're going to go this route. Okay? So if yes, they use acceleration within the equation, but no, there is no distance involved, then you're going to use this equation, A equals V sub F minus V sub I over T. Okay? You're going to use the easy cheesy acceleration equation. You stop right there. You should be able to solve what you need to solve for. If displacement or distance is involved and it has acceleration in it, and you're going to go ahead and go this route, you're going to ask, does the question give you time? Is T involved? So this is going to be part 2. Okay, if you say yes, you're going to go this route. If you say no, then you're going to go this route. Again, this is just kind of a little guidance to kind of help get you through some of these problems that are a little bit more difficult. So when you say yes, time is involved, whether it's your unknown or whether it's given to you, but time is involved, then they're only going to give you the V sub I is given to you. No, camera. The V sub I is given to you. And when the V sub I is given to you, then you're going to use this equation right here. D equals V sub I, parentheses, times T plus 1/2 AT squared. Okay? If you use the answer no, time was not involved or given to you, then that means that they must give you V sub I and V sub F. And in this case, when they give you those two variables, you're going to use the equation A equals V sub F squared minus V sub I squared over 2 times D. Okay? So those are your other equations. Here are our superhero power morphed equations that we're going to use. And I'm going to go ahead and pause for a moment and let me give you this one, because this one could be into a triangle. We know that already. We talked about it. We've already know that this one and this one can be put into a triangle. Could we put this into a triangle? No triangle. This has to be algebraically solved for. This one can be put into a triangle. I'm going to go ahead and put it right here for you, just in case if you start to like this triangle business. It is going to be the VF squared minus the VI squared over 2D, and then you have to plug the A in. And now you can rearrange and solve for it quickly instead of algebraically having to do that. Okay, let me practice a couple of problems with you, and then after that you need to practice one on your own, but yet we can still discuss and talk about it in the meetings. Okay, so let's look at the first practice problem. Oops, let me scoot this way. Practice problem number 1. It says here, a car accelerates uniformly from rest. The word from rest means that my VI, which is initial, was 0. Remember, in physics, words have number value. To a speed of V sub F, 23.7 meters per second, and T, 6.5 seconds. Find the distance, question mark D, that the car traveled during this time period. Step number 1. When solving for math equations, or these word problems that we do here in physics, I am going to suggest to you, you don't have to do it, But here's how I suggest, because they're going to get confusing and you're going to ask me, I'm going to say, did you write down all your variables? Well, then if you didn't, how do you know what you have and what you don't have? I can't help you unless you help yourself. So let's go ahead and write down all of our variables. V sub I is 0. V sub F is 23.7 meters per second. T was 6.5 seconds. Distance is my question mark. We're missing something, aren't we? Yeah, A is missing. Okay, A is missing. Now, I like to do this because this way I can go ahead and look first of what I have and what I'm missing. A was missing. That's not a problem. And number 2, the reason why I like to do this is because I can go ahead and look at my units, and all my units need to be matching. What if for some reason in time it was in minutes? Then I would have to convert those minutes to seconds, right? I can't have meters per second in minutes all together. That's not going to work. They're not going to mesh together very well. Okay? So now let's go ahead and come over here. First thing is it an easy cheesy velocity or speed equation? Well, no, it's not. Okay? Why? Because it has initial and final velocity in it. So it's going to have to do with some kind of an acceleration problem. Okay? All right, not a problem. Then let's go ahead and ask ourselves, well, is distance or displacement utilized? Yes, it is. They didn't give it to me, but it's what I'm looking for. So yes, it's part of the equation. Now let's go ahead and look over here. Well, did they give me time? Yes, they gave me time. So if they gave me time, then they must give me VI and VF, and they did give me that. So it tells me that I should use this equation right here. Again, this is a guidance. It is not 100% guarantee. It's more like a 90% going to help you. Okay? So I'm going to come over here and I'm just going to write down my equation. A equals V sub F squared minus V sub I squared over 2D. All right, so there's my equation. Do I have V sub F squared? Yeah. V sub I? Yes. Do I have the number 2 as a given? Yes. Do I have distance? I don't know it. Do I have A? Ooh, I don't have A either. I'm missing 2 of them, actually. I'm missing this one, and I'm missing this one, the D and the A. So what do? I can't really solve for this. So in this case, then, it wasn't so helpful, was it? It really didn't get me there. I'm going to have to do 1 or 2 things. I'm going to have to either go another route and say, you know what, this didn't help me, because I am looking for the distance. I have this, that's a given, okay, but I don't have this. Now I need to ask myself, can I solve for one of those 2 using another equation? Well, let's go back and let's look over here. Like I told you, this is just really a guidance. It's not 100% guarantee. Do I have the D? No, that's my unknown. Do I have the VI? Yes, I do. Do I have the T? Yes, I do. 1/2, a given. Do I have the A? Nope, I don't have that. Do I have the T squared? I do have that T. Well, if I can't use this one, I can't use this one, but I need to use one of those 2 to solve for the distance. What can I do? Instead of using this one as my number 1, I'm going to X that out. I'm going to have to work my way even more. And I'm going to go with, why don't I use this? A equals V sub F minus V sub I over T. I have the VF and the VI. I have the T. Why don't we use the easy cheesy acceleration problem first to solve for the A? Then we can plug it in over here and solve for the D. Or if you want, we can use this equation over here and we can solve for the D. Either way works. Okay? So this is a 2-step problem. Some of these problems are going to make you pause for a moment and think about it. All right, so let's go ahead and solve for this. I'm going to say VF is 23.7, take away 0 over 6.5. Okay? Go ahead and do this math. You should get something like 3.65 meters per second square. That is not my answer. That's only my acceleration. So now I'm going to come over here. You saw where I was missing? I'm not missing that anymore. I have an answer to put here, 3.65 meters per second square. Now I can come back over here, plug in my information, and I can solve for the distance, or I can come over here, plug it in, and solve for it. Your choice. Now this one right here, I'm going to tell you, if you go this route, when I see students doing this one instead of this one, the majority of the time they're going to make a mistake on this equation. And the reason for that is because they forget to, number one, square those two, or number two, what are you solving for? You're actually solving for the distance or displacement, which is down here at the bottom of the division. Okay, then they get messed up. I'm having to flip and get this D to the top. Okay, that's also a mistake. So now both of that square and the D at the bottom really throw students off. Over here, VI times T plus 1/2 AT squared equals my distance. That's actually going to be the better, easier equation to use instead of this one. Your choice though, okay? But I'm going to go ahead and I'm going to do the one that I know that I've seen was more successful with students. So D equals, and I'm going to go ahead and put an X on that. Like I said, there's more than one way to solve. VI times T plus 1/2 AT squared. VI is 0. So 0 times T is 0 plus 0. Well, then in that case, that gets to cancel out. See what I'm talking about? Your math skills. You just kind of start thinking ahead of what you can do and what you can cancel out and how to solve for the problem. Now, all I have to say is D equals 1/2 AT squared, or 0.5, because I like to convert fractions into decimals in physics, times 3.65 times 6.5 equals your answer in meters. Okay? Meters, this is truly a displacement, so you should write a direction, and the only thing I know is that it's moving forward. There we go. So go ahead and solve and fill in your blank over here. Okay? I'm going to keep going. If you need to, pause this. But let's go ahead and go to the next equation over here. The next equation. It says that a person is pushing a stroller, starts from rest. If you start from rest, then your VI is 0. Uniformly accelerating at a rate of, here's my acceleration, 0.5. What is the velocity of the stroller after? That keyword after is a VF, question mark. After it has traveled a distance of 4.75 meters. Okay, so first thing I like to do is I like to go ahead and underline what I'm looking for or what variables they've given me. I like to go ahead and put around here the variables, and then I'm going to list over here along the side all my variables. VI, VF, T, D, and A. And there's actually 5 variables. VI, since I started from rest, is 0. VF, I'm looking for. T was, well, that was missing. Normally, I like to write the word missing or just put like an X over there. Okay. D is my 4.75, and my A was 0.5. I'm going to come over here. Even though it's not perfect, it's still pretty awesome to use this. Is displacement utilized in this equation at all? Yes, it is. 4.75. Now I need to ask myself, was time utilized? Well, actually, it was missing. Completely missing. So, no, time was not utilized at all. Then I need to ask myself, oh, look at that. I just saw that I made a mistake up here. Time was utilized, so this should have been the correct equation to use instead of that one. Man, I'm so glad that I had a second to stop and look back. Because time was utilized, then we were able to say yes, and this should have been the right equation, which is the equation we used anyways. Look at that. Love it. Let's go back still. What's time utilized? Yes, it was. They're telling me that this is the equation I should use. I'm going to write it down. D equals VI times T plus 1/2 A T squared. All right, here's my equation that I have. I need to go ahead and solve for V sub F. What the world? Why are we going to use this equation if we don't even... There's not even a V sub F in here. So again, it's like you stop, you think about it, is... Oh, my brain has just stopped thinking. I wish we were in class together. Why did I say yes? No, time is not used. I'm so sorry for this. At least it's still videoed, right? So since time is not used, it's missing. That's not my correct equation. This is my correct equation. I don't know what's going on with my brain. I'm sorry. A equals VF squared minus VI squared over 2D. That's my actual equation I'm going to use. I apologize. Do I have the A? Yes. Do I have the V sub F? No, it's what I'm looking for. Do I have the VI? Yes. 2, it's a given. Distance? Yes. Well, let's go ahead and plug it in and solve for everything. I apologize again. 0.5 equals VF squared minus 0 squared over 2 times 4.75. Okay? Let's look at your math skills. Let's see what's going on here. You've got a couple of situations. Situation number 1, I'm actually looking for the V sub F, and you can algebraically solve for this, or you can come over here and say, cover that up. If I had acceleration times 2D, that would be the correct way to algebraically solve it. So that way, or you can algebraically solve it as is, like this. I'm going to go ahead and leave it like this and just algebraically solve it. I'm looking for this variable over here. First thing is I need to get those two numbers, multiply them, which comes out to, I think it's 9.5. And I need to multiply this side by 9.5. That cancels out. Multiply this side by 9.5. Okay? Now 9.5 times 0.5, we're going to have on one side, which is, if I'm correct, 4.75. I don't have my calculator on. Hopefully you're double checking my math. And if we're in class, I would absolutely tell you to double check my math. Equals VF squared minus 0 squared. 0 squared is 0, so VF squared minus 0 is not important, is it? VF squared. Am I done? No, I'm not done. Hopefully some of you in your head said, no, lady, we are not finished. Do you not see that square? I do. I see the square. And what's the opposite of square? A square root. So VF equals 2.18 meters per second moving forward. Double check my math, make sure, but please don't let that square throw you off. You've got a square root it there at the end. Looks like all of our notes are complete now. I'm sorry for apologizing for screwing that up and screwing that up earlier. Not a problem. We're going to practice so much, you're going to be like flowing through this like crazy. Alrighty. Don't forget, we have our quiz dates. We have our test date, which is going to be on a Friday. Please don't forget that our Friday is not a traditional time. If we have a 2 o'clock class, our Friday is not 2 o'clock. Our Friday class got moved. All of my classes on Friday are in the morning for 1 hour in length, okay? We are going to see each other this week when we have our meetings. Please, if you have a problem or a question here, you need to stop me and ask me. We are going to go over a few problems here in class. We're also going to go over DT-VT graphs, as well as practice problems or practice problems from homework 1 and homework 2, and the practice problems in here as well. Please ask me your questions. I don't know what you don't know unless you ask me, okay? Have a good evening. Bye-bye.